Welcome. In this session, I will discuss how to find discontinuities of a function. Recall that continuity requires three things. The function should be defined, the limit should exist, and the value and the limit should equal. So if any of the three things fail, then the function will not be continuous. So if the limit does not exist, the function will be not continuous at that number. If the function is not defined, then also it's not continuous. Finally, the limit may not be equal to the value, even if the limit exists and the function is defined. This typically happens only with piecewise defined functions. Okay. So, to give examples of each, the greatest integer function is not continuous at any integer because the greatest integer function, the limit from the left and the limit from the right at any integer are different. The graph consists of steps and there is a break at every integer. Rational functions are not continuous where they are not defined, let's say where the denominator is 0. So for example, the function x squared minus 1 over x squared minus 3x plus 2 is not continuous at 1 because 1 is not in its domain. Note that g does have a limit at 1 as you can verify. Okay. So if a function is not defined at 1, it cannot be continuous at 1. That's what. Finally, we look at an example where the function is defined and has a limit but is not continuous. This is the function which is defined to be x squared minus 1 over x minus 1 if x is not equal to 1, 0 if x is equal to 1. If you calculate the limit, x squared minus 1 is x minus 1 times x plus 1. So x squared minus 1 over x minus 1 simplifies to just x plus 1, which means the limit of this function h at 1, same as the limit of x plus 1 as x approaches 1, which is 2, but the value of the function is 0. So, of course, as I said, last thing cannot happen with rational or even elementary functions. So for a rational function, the discontinuities are where the denominator is 0. So for the function x squared minus 3x plus 2 or x squared minus 5x plus 6, where the denominator factors as x minus 2 times x minus 3, the discontinuities are x equals 2 and x equals 3. Note that at x equals 2, the function does have a limit, but it's still not continuous. If you draw the graph, it's easy to identify the discontinuities. Anytime there is a break in the graph, there will be a discontinuity. So for this graph, there is a break here at -4. There is also a break here at 1. So those are discontinuities. There is a hole in the graph here. So at -2, there is also a hole in the graph here at 4. At -2, the function is not defined. At 4, the function is defined, but the limit is not equal to the value. So it's still a discontinuity. So this has 4 discontinuities: -4, 1, -2, and 4. If you have a piecewise defined function, then you have to find the one-sided limits first and then compare them to the value. So let's check this function, defined to be 2x minus 3 if x is bigger than 3, 0 if x is 3, and x if x is less than 3 for continuity at 3. So if I calculate the limit as x approaches 3 from the right, so I take values of x which are a little bit bigger than 3. If x is bigger than 3, f of x is 2x minus 3, so it will be the limit of 2x minus 3 as x approaches 3 from the right. But now I have a polynomial, so limit equals value, which is 2 times 3 minus 3 or 3. The limit from the left will be same as the limit of x as from as x approaches 3 from the left, because if x is less than 3, f of x equals x, and that is 3. Since the two one-sided limits agree, the two-sided limit exists and is equal to 3, but the value is given as 0. Since value is different from the limit, it's not continuous. So what this means is that if you draw the graph, the right-hand segment, y equals 2x minus 3, approaches the point 3, 3, as does the left-hand segment, y equals x, but there is a hole in the graph at 3, and the value of the function at 3 is 0, so they have plotted the point not where the hole is, but somewhere else. This is what stops the function from being continuous. So this is an example of how to find discontinuities of functions. I will stop here for now. We will talk about properties of continuous functions next time.